Welcome back. We're in Projectiles Worksheet 3, number 6. Where am I at? On an icy road, the driver of a car loses control, goes off an overpass. Oh no. 4.5 meters above the road. The police determined the car traveled a horizontal distance of 15 meters before it hit the pavement below. Maybe it was snowy and they could see exactly where it landed because it made a depression in the snow. How fast was the car going when it left the overpass? Okay, remember overpasses are the roads that go over the highways there, just really other roads. So let's go ahead and let's draw that. I'm going to draw it. Let's see. I'm going to try and draw it from like a 45-degree angle perspective. Let's see if this works out. So you have some idea. Sometimes I've had students who are confused on what this means. And so this is like the road. I have a road on the top here. And then I have a road shunk going through here. Man, I normally don't draw at an angle here, but I don't think this is half bad. So the one under is the underpass, right? So this guy is an underpass. And this guy here is the overpass. That's the higher one. Okay, so they're going off the overpass. Now I'm going to redraw that so we can actually look at it. And I'm going to choose to I'm going to draw it from that perspective right there at the overpass, so then I can see how it's flying off of the overpass. So that means that here, this side view, you might say, this is like the road, and cars would be going like into the page, or they'd be coming like out of the page, like so. And then, there's some sort of, it's on like some sort of bridge, as you can kind of see there. And then the road beneath it goes this way. So there's like a road going this way or that way beneath it. And then I guess that should be like, that's behind it. So you can't really see it. So then that means that the car is up here. And the car is coming off of here. And let's say the car is pointed this way, so I got headlights on it and a steering wheel. That always helps me figure out which way the car is moving. Since the way I draw it looks like it's symmetric. This thing we know is going to fall off, and it's going to take some, parabolic arc to get down to the ground there. And now we can start labeling things we know. We know that this delta x is 15 meters. And we know the height of that thing is 4.5 meters above the road below. And what are we trying to figure out? We're trying to figure out how fast was that car going? What's the horizontal velocity, and you might even say in the x direction, what is that velocity? And that's the only thing that we're trying to figure out. Oh, okay, cool. Now we might have to figure out a bunch of other things going along with that to be able to figure that out. So let's go ahead and let's split things up into the x dimension and the y dimension, as you know to do. And I'll give myself a little bit more room to work in the y dimension because there's usually a little bit more calculations there. My delta x, 1/2 at squared plus v naught t. And I look at that and go, oh yeah, we didn't put this on there. You know that at some point when the car is falling, why is it falling? Well, gravity's pulling that thing down. That's causing some acceleration to go down. We know that acceleration is negative 9.8 meters per second squared, and nothing else is pushing it left or right. That means that the acceleration must be 0 in the horizontal dimension, giving that term 0. 0 times anything is 0. And then the original velocity, well, you don't know what that is. And specifically, that's in the x dimension, but I'm already in that column. But I'll be explicit there, multiplied by some time. Now, we do know that the delta x there, we do know this guy is 15 meters. But I don't know the time either, so I can't, I'm stuck right there. I can't solve that. But that's all right. Let's go to the y dimension. Maybe we can figure something out there. My delta y is 1/2 at squared plus v naught t as well. And let's see what we know here. Do I know delta y? Well, yeah, I know it starts 4.5 meters high, and it ends at 0, n minus start, right? And so now I have negative 4.5 for my delta y. Cool. I know the acceleration. That's gravity causing it to come down at 9.8. I don't know the time. And wait, do I know the original velocity? Isn't that what I'm trying to solve for? Well, careful. It says that the car goes off, and I believe it says, the police determined it has traveled a horizontal distance. Okay, cool. And so here it doesn't explicitly say it, but we're assuming that when it goes off this overpass here, that the overpass is level. You know, it's completely horizontal. Meaning that the velocity when it comes off with it is completely horizontal as well. So therefore, the velocity at the beginning in the y dimension is going to be 0. So we kind of have to read into that a little bit. When I do that, then I know that this beginning velocity, and that's in the y dimension there, must be 0. And now I'm just solving for time. Okay, cool. Let's rewrite that and solve for time. So here, when I add the 4.5 over to the other side, the second term there, v naught t, becomes 0, and the 1/2 negative 9.8 t squared, oops, sorry, and then plus my 4.5, I'll just write it over here. Right, the v naught t becomes 0 because 0 times anything is 0, and that's just equal to 0. Oh, okay, cool. Well, I guess I didn't need to move the 4.5 over to the other side. Let me go ahead and let's rearrange this. Since this is a degree 2 polynomial, but this is an easy one because I can just solve this using the equation solver. So that's negative 4.5 over there divided by my negative 9.8 multiplied by 2 as well. And then I take the square root. Oh, I'm running out of room here. Oh, gosh. I'm going to go ahead and take the square root of, and let me move that all over to the other side. So I have the negative 4.5, so I move that to the other side. And then I multiply by a factor of 2. And then I divide by my negative 9.8, and then I take the square root of both sides. Boom. Okay. That's equal to t. And now notice the negative and negative, I have two negatives there, and so they'll cancel out to be positive, which is good because when I take the square root of a positive number, I get a real time. And yeah, I'm sure expecting real time here. So I take the square root of 4.5 times 2 and then divide that by 9.8. You're grabbing your calculator, you're doing the same thing. And you find that time is equal to 0.96 seconds. And I store that as t in my calculator so I can use that later if I need to, because I do need to. I need to use that right there. Now when I put that in there, I can find the velocity in the x dimension here. So v naught x is equal to my delta x over time there. And I can plug that in. We know that's 15 meters over that 0.96. And I'm using the whole time there. I am not using the rounded bit. I am not using the rounded bit. So 15 divided by, I stored that as t in my calculator. And then I get 15.65 meters per second. Chunk. That's how fast I was going. Anything else? I don't think so. I think that was it. That's it. All right. Have a beautiful day. See ya.